All right. Hello?
Hello.
Hello?
Hello.
Hi there.
Good morning.
Danke schön. Auf Wiedersehen. Okay, anyway, all right, so I'm starting with yesterday's stuff because I'm going to fix my problem that I have. Everything is correct except for to right here at this point. This is the part that I did not do correctly. Because I set it as 0, even though it's not 0, it's the limit . Okay, so I'm going to fix it now. So now everything is correct. So now I'm taking the limit as x approaches 0 from the positive side of 1 over negative 1 over half, 2, right? Times my 1 over sine x times 1 over cosine x. So I'm breaking it up into different parts to show you what this comes out to be and why. So I'm taking the limit of all this, but I'm doing it by piece by piece by piece. So now, 1/2, negative 1/2. Okay, that one's good. I'm okay with that, right? Because if I take the limit of that, it's just going to be my negative 1/2, right? Times. Now, this is not sine at 0. That was my mistake yesterday. It's not sine at 0. It's approaching 0. So now, getting closer and closer to 0. So I'm getting smaller and smaller numbers. Okay, it's coming close to 0, but it's not getting to 0. But as this goes, it's going to get bigger and bigger numbers, right? 1 over 0.001. Okay, so it's like 1 over 0.001, which would give me what? 1,000. So it's getting close to 0, but it's not there yet, right? Or it's 1 over 0.000001. Okay, right? So the closer I get to 0, I'm not going to be at 0 though. I'm not going to be at 0. I'm getting close to 0. So the bottom number is getting really, really small. So if the bottom number is getting really, really small, that means this goes to what? Infinity. So this is going to be infinity here. So this part is going to be infinity times, now, for this right here, 1 over cosine of 0, okay, to the right hand is 0. So this one, it is a number, right? It is a number. It's not 0. So this one's going to be 1. So if I'm looking at the limit from the right-hand side of 0, okay, the limit as x approaches 0 for cosine is just going to give me 1, right? The limit goes to 1. So that means that this 1 over 1 is just 1. So as I do this all together, my answer should come out to be negative infinity.
So when you include the signs on this side?
Yes, it goes to negative infinity. So that's going to be a big difference because either it's going up to infinity or it's going down to infinity, right? Okay, so that's important there. Okay, so this is the fix from yesterday. Okay, so right here, indeterminate form, I'm going to go back for one of the slides. Here it is. Here it is. Finding the limit when this is an indeterminate form at C in the type of, so there's a couple different things that you're going to have. So you're going to have 1 to the infinity, 0 to the 0, infinity to the 0. There's a couple others that go along with this, which would be also, it would be 0 times infinity. I wrote down the other ones.
Wait, 0 is not going to be 1?
No, these are indeterminate forms. So it's not 0 over 0. Remember L'Hopital? We have to have 0 over 0, right?
Yeah.
So these are,
Like we cannot divide by 0.
yeah, so right here, and the other one's going to be infinity minus infinity. That's indeterminate, but it's not it has to be in 0 over 0 or infinity over infinity. And my third one, I think I already got that one. 0 to the 0.
And why infinity cannot be just 0? Because like
What?
infinity, why it cannot
Okay, we're trying to get this, right? What rule are we trying to use? L'Hopital, right? We're trying to use L'Hopital. So to use L'Hopital, we have to come up with those.
Yeah.
But if we get these, or this, or any of these, that means that we're going to have to change it to a different type of problem, or rewrite the problem. So I'm sorry these notes are out of order, but... Okay, so let's look at this. So if I'm plugging in 0 here, plugging in 0, so as limit as x approaches to 0, this is just going to be 0 times,
negative infinity.
this is negative infinity, right? So that one is the form in which I cannot do L'Hopital, right? I have to rewrite the problem. So I'm going to rewrite this problem, but see this one right here? The zero's messing me up, right? I'm okay with the infinity, but the zero's messing me up here. Okay, so I'm going to rewrite that. So to do that, I'm going to rewrite it. So I could rewrite this as ln x over 1 over x. Because if I move this to the bottom, wouldn't it be ln x over x to the negative 1, right?
Yeah.
And then I could rewrite x to the negative 1 as 1 over x, right? There's a reason for doing it like this. So now I rewrote it. And now I could actually, let's try and do it again. So if I plug it in there, that's going to give me the, again, on top, I get the negative infinity, right? And on bottom, if I get really, really close to 0, it's getting really, really small on the denominator, right? Yes? So that's going to give me, so 1 divided by a tiny number is going to go to infinity, right?
Yeah.
Okay, so this is infinity over infinity. Now can I do L'Hopitals with this problem here? Yes, now I can do L'Hopitals. So I can do it with this. So let's go ahead and do the derivative of the top. So the derivative of the top is going to be what?
Is it still working if there's on top negative infinity and on bottom just infinity?
Yeah, infinity over infinity. Positive, negative, yes. Okay, so now, what is the derivative of 1 over x? Isn't it, don't you, if for this right here, it wouldn't be the same as saying x to the negative 1, right?
Negative 1 over x.
So it's going to be negative 1 over x squared. Very good, squared. Because you're going to subtract 1, right?
Wait, we have to find derivative of the second one. We cannot do the first one.
You cannot do this.
We cannot.
You cannot do this.
Okay.
You have to be like this. And so in this form, you have to do this. Okay? So now, we did the derivative.
It's gonna be just negative x.
Okay, so now, let's go ahead and flip them over. Okay? So I'm going to make it into just one fraction here. So wouldn't this be the same as 1 over x times the reciprocal of this, negative x squared over 1,
So it's just negative x.
which is just negative x. Now, can I take the limit as x approaches 0 from the right-hand side?
Yeah.
Okay, so that's just going to be what?
0.
0. Now I can take the limit right there. So this one's going to give me 0. Does that make sense now?
Yep.
Okay, I need to rework it to make it into the L'Hopital. All right, did you guys write that down? Because I'm about ready to clear this. Okay, good. All right, so for this one right here, same thing. So if I plug it in as is, so I'm going to do this one right here. If I plug it in as is, it's going to be infinity times
0. infinity is like going to 0.
Yeah, it's going to 0, right?
So
So so sine,
of 0 is like going to 0.
yeah, sine of 0 is 0, right? So it's going to be infinity times 0. So that is my indeterminate form, right? So I need to change that up. So we can do the same thing with this one right here, right? So let's rewrite it as sine of over right here, right? Yes?
Yeah, but
Now it's going to be the limit
0 over 0.
as, so from infinity, this one's going to be 0 over 0, right? Okay, this one's slightly different. This one goes back to an identity. It goes to an identity right here. So let's say
Oh, isn't it going to be the formula?
there's an identity that goes along with this. We did this way back when. Okay, when we're taking the integration and I have sine x over x, what does that give me?
0 no 1.
1. But isn't it the same thing here and here?
Yeah.
The same thing here and here. So it would be like the saying sine of 2x over 2x.
Yeah.
That would be the same. As long as this and this are the same. So as I'm taking the limit here, okay, this is one of those weird oscillating ones that comes out. There's a long proof that comes along with this. But when I take this limit, it's going to give me just 1. Because this is an identity that we had way back when. Sine of x over x.
If it's going to.
Okay, so let's take a look at this one right here. Okay, from the left, take a look at it, or from the right. So 1 over x, so it's 1 over a number that's getting really, really close to 0, but not 0. That one's going to be what?
Infinity.
Infinity. So that one's going to be infinity minus infinity, right? So same thing right here with sine. It's not 0, but it's getting really, really close to 0 on the bottom. So that's infinity, infinity. So infinity minus infinity is another one, which I said is going to be indeterminate form. Okay, so we got to try and rewrite this somehow.
So we can just make the, like, multiply the first one by sine and the second one by x.
There's a lot of things we could do. So what do you want to try?
Like, multiply.
Cross products there?
Yeah.
So cross products,
That's not really.
it would give me what? So sine x minus x over x sine x.
So it's going to be just 0 over 0. That works.
Okay, so let's see, plug it in. So this is going to be 0 here, right?
Yeah. Minus 0. Divided by 0.
Okay, so yeah, so it's going to be 0 minus 0 over 0. Yeah, 0, 0, right? Okay, derivative of sine.
Cosine.
Cosine x minus 1 over product rule.
Sine x plus x cosine x.
Yep, so we're taking the limit as x goes to 0 from the right hand side.
It's still going to be 0 over 0.
Still 0 over 0? So we can get 0 here, right?
No, 1 minus 1. And,
Or yeah, 1 minus 1, so that's 0, yes.
and then the bottom is 0 plus 0.
0 plus 0, okay.
So one more time.
We need to do one.
Okay, do another time. So that's going to be sine.
Negative sine x, and then divided by cosine x, plus negative, minus sine,
So it's going to be minus?
minus sine x, yeah.
Okay, because right here, this product rule, so
Oh,
the
yeah,
derivative
plus.
of this,
Plus cosine
so it's going to be plus cosine
x minus x sine x.
minus x sine x. Very good. So now for this one right here, Again, we're going to get the 0 on top. All right?
It's gonna be 0 over 2.
Over, so this is going to be 1 plus 1 minus 0, so that's 2.
0 over 2.
There we go.
0.
So the limit as x approaches 0 from the right-hand side. So we had to take 2 derivatives of this. We took 2 derivatives, and now we come up with 0 over 2. So, okay. That one's okay now. So what's my answer? 0. It's okay? Questions? Yeah. That's it. Same stuff. So same stuff. I just wanted to make sure I go over some of those problems. All right. Like, share, and subscribe.